So in this section, we're going to go through different measures of central tendency. So you've heard averages a ton in your everyday life. That's really just some representative for a group of data. So there are going to be four main types of averages we're going to learn about. We've got the mean, the median, the mode, which are the ones that are most common, and the last one is going to be the mid-range. So each one gives a number near the center of the data, which is why they're called measures of central tendency. So the first one we're going to look at is the one that you're most familiar with, which is the mean. So the arithmetic mean, which we just say mean for, is symbolized by one of two things. You have an X with a bar attached to it on top, or you have this letter, which is called mu, so it's just a Greek letter. So depending on the specific scenario, will tell you what you have to use. X bar is going to be used when you just have a sample of the entire population. This mu is going to be used when you're calculating the mean of the entire population. So if you think about just students in a class, you guys are concerned with your test averages. If you're looking at a specific student's average, it's the X bar. But if you're looking at the entire population, which is your class, that would be that mu. So the mean is just going to be you sum up all the data divided by the number of pieces of data. So you take every single point. If you have n of them, you'll divide by n. So you add up all 20 scores, divide by 20. Another way to write this is using what's called a sum. So this is another Greek letter, which is sigma. So you sum up every single data point, divide by the number of points you have. So we're going to work with a specific example in calculating all of the different types of averages. So we're going to work with these set of numbers and we want to determine the mean. So all we do is we add up every single data point, and in total there's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 points. So what we're going to do is add all of these up, divide by 9. So if you go through that, it'll be 135 over 9, or the mean will be 15. The median is like the median of a highway. It's the number that's going to fall directly in the middle. So it divides it into two different sides. So the data has to be put in an increasing or decreasing order, but it just has to be ordered in some way. You can't just leave it as is. So the nice thing is when there's an odd number, you'll have one that's exactly in the middle. So you just take that to be the median. But when there's an even number, what you need to do is you need to find the average mean of the middle two. So we'll do an example with each so you can see. But let's work with this same example. This one is already in order for us, so that's nice. So I need to find the point that is going to be in the middle. So what I'm going to do is I'm going to cross off 2 on this end and do the same on the other end. 2 on this end, same on the other end. So I've taken off 4 from each side. This is the number that remains right in the middle. So the median is going to be 14. Okay. Now the mode is the most. So it's the piece of data that's going to occur the most frequently. So in this example, you've got 10 appearing twice, so that's a higher amount, but really these 14s appear 3 times, which is more than anything else. So the mode in this example is 14. If you have no repeats, so each piece of data only occurs once, there's going to be no mode, so you don't want to list everything out. You can have more than one mode. You can have 2, you can have 3, but if there are 2 modes, we say the data is bimodal. The last one is our mid-range, and all that is the numbers that's in the middle of the 2 highest, or the highest and the lowest. So what you do to find the mid-range is you take the lowest value, add the highest value, and you're finding the mean of those. So in this same example, the lowest data point is 9, the highest is 27. I want to see the number that is in the middle of those two. So the mid-range is the sum, 9 plus 27 over 2, which is 36 over 2. So halfway between 9 and 27 is 18. So that is our last measure of central tendency. So let's just do some more examples utilizing this information. The amount of money Stephanie collected in tips over 6 days is given by these following values. One day she earned 51, then 70, 54, 28, 105, and 64. We're going to determine all the different measures of central tendency. So the first thing we're going to do is we're going to find the mean. That order doesn't matter. You're just adding everything up. And then there's 1, 2, 3, 4, 5, 6 days we collected data from. So you're going to divide this by 6. So if you add all that up, it'll be 372 over 6. She'll have earned on average $62. Okay. To find the median, we've got to list everything in order. So what I'm going to do is use this original data. My lowest value is 28, so I'm going to start with that. We'll put a 28 at the beginning. My next value, that is the smallest, is going to be 51. So 51 comes after. Then it's 54, 64, 70, and finally the last value is 105. So I want to see what's in the middle. If I knock off one at each end and keep that process, I can't knock off these two because then I have no points left. So because I have an even number, I've got 2 that are in the middle. I want to go ahead and I want to take the mean of these. So the median is going to be the sum of these, 54 plus 64 over 2. So halfway in between 54 and 64 is going to be 59. So our median for this problem will be 59. Okay. Now if we go to calculate the mode, nothing repeats, so there is no mode. For the mid-range, I need the highest and lowest values. Lowest value is 28, highest value is 105. So our mid-range is 28 plus 105 over 2. So if you go through that, it'll be 66.5 is our mid-range. Okay. So we can also utilize these averages, especially in any type of course you're going to be taking, to try to figure out what you need to be able to pass a course, to figure out your class average, so you have different parts to your overall grade. You need to find your averages with whatever drops and things like that to see if you're going to be able to pass the class or figure out what grade you're going to get. So we're going to look at a specific student. The mean on their 5 exams is 81. We want to see what was the total amount of all of his scores, so his sum. So because we're told the mean, remember that's just going to be this value, x bar. That is the sum of all 5 scores divided by the number of tests he took, which is 5. So we know the mean is 81, so it's going to be the sum of his scores over 5. So all you need to do is multiply the 5 over. So you get 81 times 5 is the first test plus the second test, third, fourth, and fifth. 81 times 5 is 405. So the sum of his scores is going to be 405. Okay. Now we've got a particular student, and the mean average of their scores on 7 exams has to be a 60 to be able to pass the class. So we've got a particular student, and the first couple grades she got were 52, 72, 80, 65, 57, and 69. So she's taken 6 of her 7 exams. We want to see what does she need to pass the course. So she needs an average of 60 between these. So we don't know her last exam. Let's call it X. 60 has to be her average. So it has to be the sum of her first 6 scores plus this last one. So you add the first test, the second, the third, the fourth, the fifth, the sixth, and then our last one is the unknown. That's going to be X. She's taking 7, so her average is the sum of all of these over 7. So if you go ahead and add up those 6 tests, it's going to be 395, and then you're adding X for that last one. So to solve, multiply both sides by 7. So you get 7 times 60 is 395 plus X. So that's 420 is 395 plus X. And then if you go ahead and subtract the 395, she needs a 25 on that last test to make an average of 60. So as long as she scores a 25 or higher, she's going to pass that course. Now, if she wants a better grade and maybe wants a C in the course, she needs an average of a 70. So now we want to figure out what grade does she actually need to get a C. So it doesn't change much. All that is a new average on the other side. She needs a 70, and that's going to be the sum of those scores plus this last test over 7. So same process. When you add up those values, it's still 395 plus X. To solve for X, you go ahead and times by 7. So you get 7 times 70 is 395 plus X, or 490. Subtracting the 395 gets you that last test has to be 95. So if she wants a C, she needs to get a 95 or better on this last exam. But now maybe we have an extra rule, kind of like we do in art class. Her lowest grade on an exam is going to be dropped. So we need to figure out, what does this last test have to be so that she still gets a C in the course? So if we look at her different grades, this is her lowest score currently. I'm going to assume that's the one that's going to get dropped. So the 52 is going to get dropped, and now you have 7 tests originally. You're no longer counting the 52. You have 6 data points. So 70 is still what she needs as an average, but now I'm ignoring that 52, and we're going to have the second, third, fourth, fifth, sixth, and seventh tests to be added. So I really only have 6 tests that are calculated in my average. So what you do, when you sum all of these up, you're going to get 343. But again, you can just multiply by 6 right now to get rid of that fraction. So we're going to get 6 times 70 is 343 plus X. So same thing, you go ahead and solve, and she needs a 77 or better to get a C when one of her exams is going to get dropped. So a much better chance than that 95 she needed when that lowest test score was averaged in.